Hey everybody, this is a series of videos to help you get a 36 on your ACT math section. So let's start off with a pretty common question concept asked. Systems of equations. Sarah goes to the market to buy some apples and bananas. She buys 3 apples and 2 bananas for a total of $7. The next day, she buys 5 apples and 3 bananas for $11. How much does each apple and banana cost? Oh boy, where do we start? So we have 2 methods to attack these kinds of questions: substitution and elimination. We'll walk through both. Substitution, solving for one variable and subbing it into the other equation. So what does that mean? Well, we'll start with the first step. Let's write these kind of facts into mathematical notation. So we know that 3 apples, if you go to the store, you buy 3 apples and you buy 2 bananas, that's going to cost you 7. If you buy 5 apples and you buy 3 bananas, that's going to cost you 11. So now that we have this in mathematical speak, we can use this first method called substitution, solving for one variable and subbing it into the other equation. So let's use this equation right here. So I'll rewrite it. 3a plus 2b equals 7. Let's solve for one variable. Let's say we're going to solve for b. I'm going to solve for b because when you solve for a variable, you have to get b alone, and I would rather divide by 2 than divide by 3. So let's subtract 3a. We get 2b equals 7 minus 3a. I'll divide by 2. We then get b equals 3.5, which is 7 over 2, minus 3 over 2, which is 1.5a. So it looks kind of ugly, but yeah, this is what b equals, right? I want you to put it in terms of a. Now what we can do is plug this b equals blah, 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 blah into this. So what I'm going to do is literally I can just kind of swoop. So I have 5a plus 3 times 3.5 minus 1.5a equals 11. 11 because I'm using this equation. So I use all that. And then we can just kind of distribute this 3, and we get 5a plus 3 times 3.5, which is 10.5, minus 3 times 1.5, which is 4.5a. Sorry, 3 times negative 1.5a equals 11. And now what we're going to do is combine like terms. 5a minus 4.5a is 0.5a, and if I subtract 10.5 from this side and from this side, which is just, I'm not doing anything weird here, this is just straightforward algebra, I have 0.5, terrible 0, a equals 0.5. This means that if we divide both sides by 0.5, we get that a equals 1. Now, what we're going to do is I'm going to plug this back into the equation to solve for b. So 5 times a, which we just discovered is 1, plus 3 times b equals 11. 3b equals 11 minus 5. All I did was just subtract this side. So 5 times 1 is obviously 5. 11 minus 5 is how we get here. 6 equals 3b. I get that b equals 2. So now we get that an apple is $1, a banana is $2. And then I'm going to sub this just as a final check back into my original equation, which I did not use yet. 3 times 1, 3a, plus 2b, which we just discovered is 2, equals 7. Is this true? Well, 3 times 1 is 3, 2 times 2, is 4, 3 plus 4 is 7. So we're good. So an apple is $1, a banana is $2. So that's how you use the substitution method. Let's look at how you can use another method called the elimination method. So with the elimination method, we start off with the same kind of beginning, so 3a plus 2b equals 7, and then 5a plus 3b equals 11. Again, just to kind of clarify, we get 3 apples plus 2 bananas is 7, 3 apples plus 2 bananas is 7, 5 apples plus 3 bananas is 11. That's how we get there. Okay, adding, subtracting. So this is kind of a funky thing to begin with. It's kind of weird to think about. What we can do is we can actually multiply the entirety of each equation by a number, and what we're trying to do is we're trying to match up the beginning of each number with of the variable. These numbers are called coefficients. I'm trying to match up the coefficient of either one of these, either a or b or b for both equations. And so what I'm going to do here is I'm going to multiply this top equation by 3 and this bottom equation by 2. Just follow along with me for a second, it'll make a bit more sense. So if I multiply the entirety of the equation, you have to do the entirety of it, 9a plus 6b equals 21. And I'm going to multiply this bottom equation, the entirety of it, by 2. So 10a plus 6b equals 22. Now, what I did was I got the coefficient of b to be equivalent. And now what we can do here is we can literally subtract downward. It's kind of a weird thing to think about, but what I can do is I can subtract downwards. 9a minus 10a is negative 1a. 6b minus 6b is 0. 21 minus 22 is negative 1. This gives us a equals 1 if we divide by negative 1. So this is how we can get our value for a. I'm going to slow down one more second. You can literally subtract these two equations. 9 minus 10 is negative 1. 6 minus 6 is 0. It can be 0b, but 0 times any number is 0, so that's why I didn't write 0b. 21 minus 22 is negative 1. We divide negative 1 by negative 1 to get a alone. A equals 1. That's what we did there. And all I did was I multiplied this entire equation to get these coefficients to be equal. And so when you're doing this kind of trick, it's actually a lot faster, but you just have to look at this equation and be like, what can I multiply a by for this equation and this equation so that they equal each other? Well, you can do this little trick where, if I multiply this equation by 5, and I multiply this equation by 3, I will then get both a's to be 15a, and then I can do the same exact thing. So it's just a little bit of like mental math ahead of time, and then you get this really quick way of solving it. And now I'm just going to plug a back in, so I have 5 times 1, whoopsie daisies, plus, oh my goodness, 3b equals 11, and then we'll just solve, so 3b equals 11 minus 5, you've seen this before, 3b equals 6, b equals 2, so then we have an apple, $1, banana, $2. And so what I gave you guys is two different ways of looking at the same problem, two both very good ways. I prefer the elimination method, but both work totally fine, both will give you the answer, and both are reasonably fast. So I'd recommend giving both a try, seeing what you like more, and then just running with one method. All right, I'll catch you guys later. Like, subscribe, follow. Thank you.